let's complete the square. So we're going to complete the square to solve x squared minus 10x plus 4 equals 0. This is a quadratic equation. We know something that is quadratic looks like this. ax squared plus bx plus c equals 0. Remember that if you have something that is quadratic, the graph is going to be a parabola. And the highest power of x is 2. And the powers of x's are positive integers, so 1 and 2. Notice there's an understood power of x to the 0 right here. A, b, and c are real numbers. A and b are what we call coefficients. A is the coefficient of x squared, b is the coefficient of x, and c is our constant. So looking at our problem here, what is a? Well, we see a is 1. There's an understood 1 right here, right? B is the coefficient of x, so it's negative 10. And c is the constant, so it's 4. So the first step, if a is not 1, we're going to make it 1 by dividing every term by a. Well, we see a is 1 here, so we're good. Now we're going to move the constant to the right-hand side. So I have x squared minus 10x. So here's the constant, plus 4. So we're going to move that to the right-hand side. So we're going to get x squared minus 10x equals negative 4. Here's the part where we actually do the completing the square process. We're going to take the coefficient of x, not x squared, common mistake, coefficient of x and multiply by 1/2. Okay, so the coefficient of x is negative 10. So we're going to do 1/2 times negative 10. And that's like negative 10 divided by 2, so we get negative 5. So that's the first step right here. Multiply 1/2 by the coefficient of x. And then we're going to square that result. So we're going to square it. And it says, hence, leave it in this form. Now you may be wondering why it's b over 2a. Remember, our a is 1. If our a was not 1, we would have had an a. We had divided every term by an a. So the 2 right here, this 2 came from multiplying by 1/2. So in our case, we still have b over 2 because a was 1. So b over 2a because our a was 1. So this is still true. We're going to square it though, and it says leave it in that form. So I'm going to leave it as negative 5 squared. And I'm going to add to both sides up here. Remember that this is an equation. If I add something to the left-hand side, I better add it to the right-hand side. So that's what I'm doing right here. I'm making sure that I don't violate any math rules. So I have x squared minus 10x. Now I'm going to add my new term to both sides. So plus negative 5 squared on the left-hand side. And then rewrite negative 4. But on the right-hand side, I'm going to put plus negative 5 squared. And again, we're going to leave it like that on purpose. Okay, then step 4 says we're going to factor this thing. Okay, well, if you wanted to rewrite it, you could say x squared minus 10x plus 25, and you could factor that. And maybe that's easy enough to factor. But sometimes we're going to end up with fractions in here, and so it would be nice to know if there was an easier way, a way that worked every time. So turns out there is. We're going to look at this. This is x squared minus 10x plus negative 5 squared. So there are two things that are being squared. We have a rule in algebra that says that a plus b quantity squared is a squared plus 2ab plus b squared. So in our example, this was just a formula in general. In our example, we have x plus some number squared. That's what we're trying to get, right? So we actually have this, if you were to expand it out, would be like x squared plus 2 times x times that number plus that number squared. If I just sort of follow the same form. Okay, so what we've done here, notice we have an x squared. Here's an x squared. And then this negative 10x is like this term in here. We have the x, and there's a 2 times some number. How do you get rid of a 2? we multiply by 1/2. Okay, so then you'll just get that number in the back squared. So if you want to factor this very nicely, very easily, we look at the two things that are being squared and we rewrite them. So x squared is here. X is what's being squared. So this is an x. And then we look in here. You have -5 squared, so -5 is what's being squared. And we just rewrite it. Okay, and on this side we have -4 plus, well, -5 squared is positive 25. Okay, so before we continue, let's just take a moment and make sure you believe me. You don't think I made up some crazy math? So if we take x minus 5 squared, that's the same thing as x minus 5 times x minus 5. Let's FOIL it. We get x squared minus 5x minus 5x plus 25. Okay, so that's x squared minus 10x plus 25. And so again, this is my scratch just to check it. But x squared minus 10x plus 25. This says x squared minus 10x plus, well, it says -5 squared. But isn't that the same thing as 25? So again, we're going to practice this process over and over and over again. If you create this perfect third term the way we did, recognizing this pattern every time, we have to undo this 2, so we get x and that number. You undo the 2 by taking the coefficient of x and multiplying by 1/2. Then you have that number and you're squaring it and put it in the back. If you have something like this, it always factors to the two things that are being squared in your set of parentheses. Okay, so hopefully you'll believe me. This will get better the more practice you do. But let's continue from here. So we have x minus 5 quantity squared equals what? Well, on the right-hand side, we're going to combine those two values. We have -4 plus 25, or 25 minus 4. So we get a 21. Okay, now we're going to solve for x. Well, x is under that root, right? So we're going to, I'm just going to rewrite it just for now. X minus 5 squared equals 21. I'm going to rewrite it so you can see the next step very carefully. To get rid of this guy right here, that power of 2, that's a square, I'm going to take a square root. If I do something to the left, I better do it to the right. I have to also make sure I do a plus or minus square root. Okay, so over here, we see this square root. This squared will cancel each other out. They are inverse processes. So we end up with x minus 5 equals plus or minus square root of 21. We need x by itself, so x equals 5 plus or minus square root of 21. Now, that may only look like one answer, but we actually have two solutions. We have x equals 5 plus square root of 21, or the other answer could be x equals 5 minus square root of 21. Those are our two answers.